Okay, let's take a look at limiting reactant product here. One thing I like to do whenever I look at anything that involves stoic is to first look at what my ratios are. And I do this by looking at my coefficients. So I've got 2 NaBH4s to every 1 I2s, to every 1 B2H6, to every 2 NaIs, and to every 1 H2s. Okay, so as I'm looking at these, what I want to know is that I'm going to have twice as much of this, okay, to react with the I2 to produce the equal quantities of I2 to B2H6. All right. Now, when I read this, okay, it says suppose you use 1.203 grams of NaBH4 with excess iodine. Excess just means we have enough iodine to react with all of the NaBH4 that is provided. All right. So in this case, this is the limiting reactant because we've got more than enough of this. Okay, the iodine, and it obtains 0.295 grams of B2H6. Okay. So when it says obtained, what this is inferring is that this is what was done in a lab or an experiment. Okay. Sometimes it'll actually say a student collected this or obtained this. All right. So you want to be aware of that because where we're heading with percent yield is the actual divided by the theoretical times 100. Okay, and the actual, this number here is what we find out in the lab. The theoretical, okay, in theory, is what we do on paper. Okay, so we want to compare what we do on paper to what actually happens when we do this in real life. There's a lot of things that kind of actually get in the way of this reaction happening. As we'll learn farther down the road, some reactions actually don't go all the way to completion. Sometimes they actually kind of teeter-totter back and forth. All right, but that's for a different day. So in order to do this, we need to get this, our theoretical value of B2H6 established from our NaBH4. So what we're going to do is this. We're going to do some basic stoic, 1.203 grams of NaBH4. And I want to get this into moles because when we're going to compare reactants with products, I can only do that if I'm doing it in moles. Okay, so I'm going to take this, I'm going to use my atomic mass here. So I've got 1.203 grams of NaBH4 and 37.84 grams of NaBH4, and that equals 1 mole of NaBH4. Okay. Now I could stop here. I'm going to cancel my units out, divide them out, and this will give me moles of NaBH4. However, I really don't want to stop there because I really need to get into moles of B2H6. And actually I need to get into grams of it. So I'm going to go another step further and establish a mole ratio. Okay, so for every 2 moles of NaBH4, it's going to produce 1 mole of B2H6. So I'm going to divide this, because if I were to stop here, my units would be in moles of NaBH4. I'm going to divide this by 2 moles of NaBH4. And the reason why it's 2, because there's a 2 to 1 ratio. So here's my 1 mole, or 1 ratio for B2H6. Alright. So what that's going to give me is that's going to give me the number of moles of B2H6. Okay, now I'm going to go one step further. I'm going to do this. This is an easy way if you run out of space to just continue what we're doing, because we're going to end up plugging this all into our calculator anyways. I'm going to take it one more step, and I'm going to transfer this into grams, because then I can compare the theoretical grams to the actual grams. So right now I'm going to divide out some units so I know what I'm dealing with. Right here, where I leave this, I'm going to have moles of B2H6. Okay, and so I'm going to put 1 mole of B2H6 on the bottom, and then I'll put the molar mass on top. Okay, and when I do this, I can then divide out my units. Okay, it's really important that you do this. This is while it seems tedious, it also saves us from making mistakes. Okay, and we really, 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 really like to stop the possibility of mistakes occurring. Okay, so when I do this, I multiply what's on top, the 1.203 times 1 times 1 times 27.67, and then I divide that by 37.84 and also by 2. When you do that, you should get a number that looks like this, 0.4398. And my units here, because I look at my last spot, okay, my numerator, last spot, I get 0.4398 grams, and it's B2H6, which is perfect. This is my theoretical, okay? So now I take my theoretical, place it in the denominator, 0.4398 grams, B2H6, and I'm going to put my actual on top, which I got from the problem up here, 0.295 GB2H6. Our units actually cancel out or divide out. Sorry, Miss Chang. Okay, we multiply it by 100 to get a percentage, and we're at 67.08%. I'm going to do a quick check here to look at my sig figs. I had 4 here and 4 here as well. Okay, and we started off with 3 and 4, 4 here, so I'm going to make this 67.1 percent yield, and it's B2H6. Okay, so there's our answer. Circle it so that the AP reader can give you credit and find your answer really easily, and that's how you can work this. Now, there's other ways you can do this. You can actually do your calculations at any given point. Okay, that's fine as well. This is one way to just string them all together so that you can punch them into your calculator at one time. And there you go.